Hi, in this video we are going to implement the Queen's problem together. So I'm going to create a new project, Queen's problem. For example, I'm going to create a new class, one in order to be able to test it, and default package. It's not a good programming practice, but for just demonstration purposes it will be good. And I have a Queen's problem class, for example. I'm going to store a Queen's array. It's going to store integers, the references, I mean the indexes. So Queen's array, and I'm going to have a private int number of queens. And as I said earlier, because it is a quadratic chessboard, I mean that our chessboard has the same number of rows as the same number of columns. So we could say that the number of queens, it is equal to the number of rows, and which is equal to the number of columns. So you can rename this variable according to personal preference. It's up to you. The constructor is going to get a number, the number of queens, and as I said earlier, because it is equal to the number of rows, number of columns, we should provide the number of columns, whatever. So the queens array is equal to a new integer with number of queens, and number of queens is equal to the number of queens. Okay, so we will have a public method, public void solve Queen's problem, and we just call the arrange queens from 0 index, and we are going to create this method, this arrange queens. As the names would suggest, it's going to get a row index, and we're using backtracking to print all possible placements of a queen on an n times n chessboard, so that they are non-attacking, they cannot attack each other. In this case, the number of queens is equal to the great N, as we have denoted the size of the chessboard. So we have to iterate through int I equals to 0, I less than the number of queens, I plus plus, and we have to check, it is a basic method for backtracking algorithms, that there will be a if method that's going to check something, and we have to check whether the place, the given place, is valid or not, I mean valid for the queen. So we have a row index and I. Okay, and if it's okay, if it's a valid place, then the queen's array with the row index is going to be the I. So we place the queen to this index in the queen array, and we just have to check whether the row index is equal to the num of queens minus 1. It means that there's a solution, so we just print the queens, and else we have to call this method recursively, arrange queens with the row index, but we have to increment the row index. As we saw in the theoretical video, we keep incrementing the row index during the algorithm, and this is exactly what we are doing here. So I'm going to get rid of the lines. Okay, is place valid, I'm going to create this method. It's going to have a row index and column index, and we have to check whether we have to iterate through int I equals to 0, I less than the row index I++, and we have to check 3 cases. If you are familiar with chess, I'm not quite familiar, but I know these basic rules, that if there's a queen in this position, and if there's another queen on the same row, then they can attack each other. So we have to check this, and we have to check for the diagonal attack routes, because the queen can attack someone if it's on their diagonal path. So we have to check for this, and have to check for the descendant neighbors and ascendant neighbors. So I think it's going to be straightforward after implementing it. So if the queen's array dot I is equal to the column index, it means that we have to return false, because it means that they are on the same column. So they are aligned, they can attack each other, and we cannot place 2 queens that can attack each other, because the base problem is that how to arrange n queens that they cannot attack each other. So we have to check this, and of course we have to check whether the I minus the row index is equal to the queen's array that I minus the column index. And in this situation we have to return false, because it means that that it is the ascending neighbor. I mean, for example, here is a queen in this position and another queen like this, and it is the diagonal neighbor, so they can attack each other. And we have to check it for the this is the ascending, and we have to check it for the descending neighbors. So if I minus row index is equal to the column index minus the queen's array that I, we have to return false, of course. So we should check, as you may see, that we should check whether the absolute value of this queen's array minus the column index, because it's the same, but we have multiplied it with -1. So we check for the mass that apps, then there will be just one if here, but I think it is straightforward because have to check for 3 cases. One, if they're on the same column, so they are aligned, and the queen can attack in 2 different directions, I mean 3 different directions, and that's why we have 3 ifs here. Okay, so anyway, we have to return true, because if we done this 4th cycle and we haven't returned false, it means that the place is valid. So we can place our queen that position, and that's why we do this here. So we just have to construct this print method. Okay. And number of queens, we have the number of queens, so just for int I equals 0, I less than the number of queens, I++, for int I equals to 0, j less than number of queens. We just iterate through. It's a 2-dimensional chessboard, n by n, so I think it's pretty straightforward that we have to use inner for loops. And if the queen's array that I is equal to j, it means that there is a queen, so we denote queens with the help of, for example, a star with spacing, and else it means that there is no queen. We are going to represent it with something like this. Okay, so let's test it. For example, in the theoretical video we saw the 4x4 chessboard, queen's problem, of course, new queen's problem, for example, for 4, and I guess that there may be more than one solution to the problem. We just stopped at the first solution, but let me check whether I think the solution will be symmetric. Oh, I think I forgot to add some spacings here. System out println, and 1 maybe 4, 1 for here maybe. I'm not sure. No, 1 for, I think that we should do it like this. Okay, so as we have seen in the theoretical video, there's a 4x4 chessboard, and I think that was the solution we have seen. The first queen for here, the next one here, the third here, and the fourth is here. And there's another solution. Of course, it is symmetric for the diagonal. This is the diagonal, the 0, 0, or 1, 1. It depends on the start of the indices. And this is the diagonal. We just have to transpose our matrix. If the mathematicians call it transpose a matrix. And that will be the second solutions. And the 8x8 queen problem is if we run the problem for 8x8 chessboard and we want to place 8 queens, and there may be a lot of solutions for this problem, as you may see. That this is the first solution, for example. And if you see, if we place the queens like this, they are not able to attack each other in this position, and it's good because that's the problem itself. We wanted to locate n queens in order to not to be able to attack each other. So we have solved our problem. Thanks for watching.